So this is the video for section 2.1. 2.1, we're going to talk about the distance formula. We're also going to talk about the midpoint formula. And so it's a fairly easy section, relatively quick to do. So the first thing that we're going to define is the distance between two points. So it's going to be x2 minus x1 to the second power plus y2 minus y1 to the second power. And that's going to be the distance between 2 points, right? So let's say that this is x1, y1. And let's say that this is x2, y2. So the distance between those two, we're going to use this formula to find the length of that segment, if you will. So for number 23, I'm going to define this point to be x1, y1, this point to be x2, y2. So then the distance between point 1 and point 2 then would be the following. So we'll do 5 minus 3 to the second power plus 4 minus negative 4 to the second power. And so I'm going to clean this up a little bit here. So 5 minus 3 is going to be 2, so 2 to the second power. Now 4 minus negative 4 is the same thing as 4 plus 4, so that's going to give us an 8. And then of course, if I square each one, I'm going to have 4 plus 64, which will be the square root of 68. So then I can go ahead and clean up 68 a little bit. So 68 will be, it's the same thing as 4 times 17 will be the square root of 4 times square root of 17, which will be 2 square roots of 17 units. So that's the distance between P1 and P2. Looking at number 25, we're going to repeat the process again with the formula. So basically the distance between P1 and P2, again, I'm going to label them x1, y1, x2, y2. So it's going to be 6 minus negative 3 to the second power plus 0 minus 2 to the second power. So 6 minus negative 3 is 9. So it's going to be 9 to the second power plus negative 2 to the second power. And so this is going to give us 81 plus 4, which is a square root of 85. And so we're going to leave it as a square root of 85 units. If it's divisible by a perfect square, you know, perfect square would be 4, right, 9, 16, 25, and so on and so on. All right, so number 29. We're going to do with 29 is we're going to do the same thing. We're going to find the distance between these 2 points. So this is going to be x1, y1. This is going to be x2, y2. So the distance between these 2 points, let me fix that there. It's going to be 0 minus a to the second power plus 0 minus b to the second power, which would be a squared plus b squared. So what this is telling you is that the distance between any point and the origin can be calculated as a squared b squared. So for example, let's just say that P1 is 3, 4, right? And P2 is the origin. And so this result here just basically tells me that the distance between these 2 points would just simply be 3 to the second power plus 4 to the second power, which is 9 plus 16, which is the square root of 25, which is 5 units. And so you can see that clearly that's a little bit easier to do if you have the distance between the origin and the point. For number 31, what we're going to have to do is we're going to have to figure out if this is a triangle, a right triangle. So the first thing that I'm going to do is I'm going to find the distance between A and B. And I'm just going to go ahead and write it out here. So this is going to be 1, oops, not negative 1. It's going to be 1 plus 2 squared, right? Because it's 1 minus negative 2. And this is going to be 3 minus 5 to the second power. So for this one, it's going to be 3 to the second power plus negative 2 to the second power, which is 9 plus 4, which is a square root of 13. So that's the distance between A and B. Then I'm going to find the distance between B and C, right? And so for that one, what I'm going to do is I'm going to do negative 1 minus 1. squared plus 0 minus 3 squared. So negative 2, that's going to be negative 2 to the second power plus negative 3 to the second power, which is going to be 4 plus 9, which is going to give me the square root of 13, right? So then the last one I'm going to find is the distance between A and C. So negative 1 plus 2, right, because it's a negative minus a negative, plus 0 minus 5 squared, which is going to give me 1 squared plus negative 5 squared, which is 1 plus 25, which is the square root of 26. So now, if I'm looking for a right triangle, right, in this case, the distance here would be negative 13, negative 13. So the smaller value is going to be the legs, and then the larger value of all three is going to be the hypotenuse. And I'm going to see if this actually gives me a right triangle. So then I am going to say that the square root of 13 squared, so remember I'm going to use a squared plus b squared is equal to c squared, right? Plus the square root of 13 squared, does it equal the square root of 26 squared? So this is going to be 13 plus 13 is equal to 26. Obviously that's a correct statement. So then the points A, B, and C in fact form a right triangle, right? So let's say if I make this B, make this C, A, B, and C. So, all right. The next one is number 37, which is the midpoint formula. And the midpoint formula is fairly straightforward. And so the midpoint formula is just going to be x1 plus x2 divided by 2, and then y1, y2 divided by 2. So I'm going to label this x1, y1, x2, y2. So then this is going to be, right, I can do 3 plus 5 over 2, and then 4 plus negative 4 over 2. And so what I'm going to end up with is 8 over 2 and 0 over 2, which is going to give me the coordinate for 0. So in other words, if this is P1 and this is P2, then here in the middle would be my midpoint, which would be 4, 0. And that's number 37. So number 41, it's the same thing. I'm going to label them x1, y1, x2, y2. So the midpoint here will be 6 plus 4 over 2, and then 1 minus negative 3 over 2, right? So remember, it's going to be y2 plus y1 over 2, or y1 plus y2 over 2. You're going to get the same value. And so here we got 10 over 2, and here we got negative 2 over 2. And so that's going to give us 5, negative 1. That's the midpoint between those two values. And I believe that is the end of 2.1. Thank you.